Hello, everybody. My name is JJ. I'm going to share my screen here and talk about some slides, but bring up some slides. But my goal is to kind of show you the code and kind of where we went with this. I'm also what they call a whiteboard presenter. So my goal is for you to learn something from my talk. I know I've been to many conferences in the past where you're never too sure why you're actually in that room. So I want to give you the opportunity to ask those questions. So don't hesitate to ask those questions. However, Calvin suggested it, and Calvin, please interrupt me whenever you want. I like to pivot. Right. Okay, so let me share my screen here. Well, actually, first let me bring up my slides here. So the talk is we accidentally created a serverless application. And again, hi, I'm JJ, developer advocate. And I really do have the email address of awesome@ibm.com. You can absolutely get me there. And if you want to find me on Twitter, which is where I usually communicate with most people, is at JJ Asghar. All right. So wait, what? Hold on. You accidentally created a serverless application? You're probably asking your first question. What? Like, how do you accidentally create a serverless application? It's kind of weird, right? Like the whole world of serverless is new and hip, and that's how people are trying to move towards. And it's something you don't really just stumble into, right? Like you have to spend your time. You hear all those like really cool, thought leaders out there talking to you about building microservices and stuff like that. And you come along to a gray beard like me. Yes, I have a lot of gray in my beard. And I'm just like, yeah, I totally fell into this backwards. It's very confusing, but that's kind of the story, right? Where I want to show you the path that we went down to run into this weird world of serverless that turns out was actually really beneficial for us. So let's talk about the problem in general and where we kind of came from it. As a developer advocate, one of the largest challenges I face is to teach people how to use our company's products, right? Like it really is. Like I can talk to you as from one to many about stuff in like OpenShift or Kubernetes and things like that, but unless you actually get your hands on that technology, it doesn't stick. Frankly speaking, like workshops are the things that actually give developer advocates the biggest bang for our buck because people actually get their hands dirty. To do this well, you have to create these things, right? You can't just like say, I want an OpenShift cluster. Like there's actual infrastructure around building all these things. And you need these environments to be disposable. Yes, of course, you can use like something on your laptop and whatnot, but back in the days of conferencing and soon, hopefully soon again, when we start getting together as humans, like, I don't expect you to download a Kubernetes cluster to your laptop. That's ridiculous, right? Like I need to give you something around there. As an IBM employee, I get to use the IBM Cloud, and I had to figure out a way to programmatically create all these clusters. But the challenge with, and something we don't really talk about very vocally is, or I guess we do talk about vocally without realizing it, is IBM Cloud is designed for long-term production usage. It's not designed for ephemeral instances, right? Like it's not like Kubernetes and OpenShift is not designed to spin up and spin down clusters. You're supposed to iterate inside of the cluster, not spin up a new cluster to do dev work, to destroy it, and then spin up a QA cluster. Like you're supposed to iterate inside the cluster because it's supposed to be kind of static and only be updated when new releases come out. So IBM Cloud is designed to be production ready. So when I'm coming in as an IBMer trying to create ephemeral teaching environments, because obviously I don't want people to abuse my workshops, it becomes a problem, right? Because now I'm going against the grain of how the cluster is designed. So we created, we often create systems to work around this, right? Like we created different ways of doing it. And updating the deployment process was so heavy-handed, right? Like we had to deal with all these different situations. And I realized in the process of creating all these workarounds, I had actually created a serverless application, and we'll get to that, me actually getting there. And this blog post that eventually I have a link at the very end that actually talks deeper into this, details on how I accidentally built this. And I leveraged automation, serverless, and Python to just basically glue in this world that now I can show, because it's pretty cool. So let's keep working with that. So let's talk about the actual iterations of what we went through, right? I'm an old sysadmin, right? I'm a DevOps practitioner, or whatever you want to call me nowadays, SRE. I don't even know what the term is, but that's where I come from. Like, I use Bash and Python to glue things together to make sure that your multi-million-dollar corporations can run their applications. That was supposed to be a joke. But you know how it is, right? There's all these sysadmins out there, and the world runs around Bash and Python. And we obviously started with that. We started with good old Bash, right? Of course, the very first thing we ever did was when we needed to spin up 30 clusters, we created a Bash for loop that was just basically an application called IBM Cloud. That's what the CLI command was, which does a ton of stuff, that basically just did a for I and sec 1 through 30, send a bunch of requests in. Funny story, I might have overran the API by accident with that for loop, which is actually kind of what you see here. This is kind of what we ended up doing. Oh, no, this is actually a different version of it. Originally, I had a sleep in here because I accidentally sent too many requests too quickly and overran the API. But we ended up creating just basically a massive for loop that went through and made sure that everything kind of came together, which was the first iteration. It was not great, not horrible, but basically all I had to do was change out this version number here. That's a really old version, but you get the point. And I'd be able to spin up n number of clusters where n was the difference between the numbers. Then over time, we ended up getting a little bit more advanced, right? Like, as you can tell, this is a significantly big difference when it just comes to simple Bash. And we ended up having to put that sleep in there because obviously we overran things and sent way too many requests all at the same time. And it just started getting weird. And as you can see here, we even need background and stuff. So another problem we discovered over time was that when we sent all these requests to the cloud, basically they would start at different times, right? Like when you send a request in, there's all this other stuff that happens in the background to request all the VMs or the bare metal or whatever you're doing, and different things would happen at different times. And we actually had to figure out a way to parallelize. Sure, let's go with that. The request, and it turned out we ended up figuring out that we can just background and just create one request each one. But the point I'm trying to get at is this was an iteration of it, right? Like, this is not great. this is not what you should do. This was one of those things when you realize that things are just going really, really pear-shaped. Funny part is I still have a couple engineers that actually do use this, and I yell at them every time I find out they do, but that's a different conversation for a different time. So over time, we were like, okay, this is obviously not working. We needed to figure out something better. So we came along to the Ansible IBM Cloud community plugin. This is when we started playing around with Python to actually start doing a little bit more intelligent work, right? Like, we're at a Python conference. We're all Pythonistas here. We all appreciate the beauty of Python. And we tried to shove our problem set into Ansible because, obviously IBM owns Red Hat now. And what is Ansible really good at doing, which is parallelism, I can't say that word. So, it seemed like a natural progression. But funny story, turns out the Ansible IBM Cloud plugin, community plugin, that is not this is just one of the plugins, and the one we found didn't actually do what we wanted to do. It was actually focused on a lot of the other things of IBM Cloud instead of the Kubernetes or OpenShift clusters that we just needed. Like we needed a way to spin up a bunch of clusters, and this Ansible plugin did everything minus that, right? Like it was really, really weird. You would think that we were focusing on Kubernetes and OpenShift, and this community plugin was dealing with like cloud object storage. And we're just like, what the hell? It seems weird. We tried to extend it. It went a little bit, that went a little bit weird, and I'll get into a little bit more details from there. So we decided to take another turn. Of course, like with all DevOps practitioners out there, we have to touch Terraform at some point. We ended up actually leveraging Terraform for quite a while, but it didn't keep a really good way to keep our state files in sync. This was not in the proto Terraform world. I mean, obviously there's a lot of better versions out there now. But at the time we were doing it, the state files were a little bit funky, and I wasn't the only one doing this. I had a team of people. It wasn't just me, which I haven't even mentioned. This was 3 or 4 of us trying to do this all at the same time. Yes, I was kind of the tip of the spear, but I had engineers behind me that would actually go off and go like take the things that I figured out and kind of ran with it so I could iterate better. And when you have multiple different state files flying around the place, and we didn't have a really good solution for it, it didn't stick. We actually ended up making a small little Go app at one point that templatized our Terraform plan, then ran Terraform for us to actually do it. And then when we realized we were like creating a massive, it was just weird, right? Like across the board. I learned a lot about Go templating though, which was unbelievably powerful, which is great if you're playing in the Kubernetes space or OpenShift space, because now it opens up, it kind of opens up the engine, if you will, to understand how Go talks to the templates that a lot of like the Helm charts and things like that use to be able to work with. But we had to jump through so many hoops to do it. So it got kind of funky. So when we went back to Ansible, right? Like Terraform failed us. So like, I guess we're back to Ansible. And we ended up, and one of the engineers, his name was Mofi at the time, ended up actually creating his own Ansible module to do exactly what we needed to do. Funny story, he was a practiced Go developer, and he actually learned Python specifically to do exactly what we needed for Ansible. And he open sourced it. I'll actually be showing it here in a little bit. But it was just basically, we created a couple of simple modules that did the requests we needed, basically sent the request of that original bash script, but wrapped it in Python and programmatically got that information that we had to put into an environment variables to be able to actually do. So now all of a sudden we were able to leverage the Ansible workflow and create a very simple playbook that we were just like, I want 30 clusters, and Ansible went off and did it. At this time, we finally realized we needed a shared kind of bastion node to do this. And that's kind of where the first iteration of us getting that was. And don't worry, I'm going to get to the serverless stuff very soon here. In the process of playing around with Ansible, we discovered Ansible Tower and something called AWX. AWX is the upstream version of Ansible Tower, if you didn't know. It is really cool. If you play it with Ansible at all, if you use Ansible at all, I strongly suggest looking at AWX or Ansible Tower if you can afford it as your bastion node. Your bastion node, I mean, you're gonna have, if you have more than just you orchestrating work, you really should have some central location with RBAC and a way for everyone to know what is happening and whatnot. And AWX gives you that opportunity. Because Ansible normally is a push mechanism, you push your changes out to everything. Having AWX do that allows you to see it and actually see who's done what where. And also there's actually an API on top of AWX that allows you to do some really nice things so you can abstract away a lot of the complexity. And that's where kubeadmin comes into play. We ended up writing, or actually I should say Mofi did, and we still use it today, an interface on top of IBM Cloud, which actually gave us an API to do post requests to AWX to kick off our Ansible playbooks to run this. Now, if you're already listening here and you kind of caught that, we wrote a web app to talk to another web app, to talk to Python, to make a request to the IBM Cloud. Yeah, you might have heard some of the things that are like, well, why don't you just, do a little bit more programming and, create a serverless app? Well, interestingly enough, that's exactly what we did. So we ended up leveraging something called IBM Cloud Functions that we had to build an interface to having these requests done. So when you send a request in, normally you would use an issues, and we had an issue tracker inside of GitHub. So we wrote, or actually I should say I stole some code from a coworker of mine who did some other requests for it and grabbed a way to parse through a GitHub issue. And then, unfortunately, I can't open source that, but I can at least show you the interface here in a little bit, where it parses through the interface, the GitHub issue, and then takes all the requests and then pushes it into basically a script that we would run to be able to kick off to kubeadmin, which eventually talked to AWX, which eventually talked to Ansible, which eventually talked to IBM Cloud. So there was a really neat part about using these cloud functions was that we actually made caps on the requests. So I had a couple times where I had some developer advocates would come to me and be like, JJ, I need 1,000 clusters. And I'd be like, what the hell are you doing? Like, that's a lot of clusters. They're like, oh, I'm expecting to have 1,000 people. I'm like, okay, well, that's a different conversation because it'll cost money. But if you're just putting a request in and you need like 100, well, we cap at 75 because of limitations of the way we've set everything up. You can only have 75 clusters, for instance. So then programmatically, we were able to check against stuff, which is really, really nice. It gave us a way to have accepted and reasonable requests around it. So it's really, really powerful. And this was all written in Python too, which I will show here in a moment. Unfortunately, I don't have the logo for this one, and I have never been able to find it, which is a little bit frustrating. Which is we ended up, one of the iterations we had was we leveraged something called schematics, which is a way to deal with that initial terraform workflow problem or stateflow problem. Schematics is a product on top of IBM Cloud where you can basically get, I'm not supposed to say this, but I'm going to just say it because we're all friends here. The same level of support that you get with something like Terraform workspaces through like Terraform Enterprise, we have something called schematics, which is a gem of IBM Cloud, which gives you that same level of control over state files on the IBM Cloud. This is important to recognize that this isn't just on IBM Cloud. So you can actually have a state file that has AWS resources inside of it running in a schematics workspace to control your AWS instances. So if you do play with state files at all inside of Terraform, schematics is free. Yes, FREE on IBM Cloud that you can kind of start playing around with to see if it's worth it. There's some really interesting portions with it. And we did experiment for a little while leveraging schematics as our actual control plane when we were playing with the Terraform stuff. But we ended up moving moving away from it and going into something called Code-Engine. That's actually the t-shirt I'm wearing right now. Code-Engine is our serverless platform. With Cloud Functions I guess Code-Engine is the next version of our serverless platform. The closest analogous to it would be something like Lambda. That's not 100% true because it's actually Knative. And on top of it, where we ended up building a bunch of containers inside of Knative to actually run our our system. So if you take a look here, this is more or less the application we created. And as you notice, this is pretty close to what's a good word for it? A serverless application. So if you take a few moments here, someone enters the request inside of the enterprise. We have that GitHub validator to make sure that this is that cloud function I was talking about. And then from there, we have this code engine grant cluster API and this issue tracker. Every 15 minutes, this issue tracker runs, parses through our GitHub issue tracker, checks to see if it's Kubernetes or OpenShift, and then sends one of the requests to that API, which talks to Terraform, which is schematics, which is actually not 100% true now, and I'll show that in a minute. And then it sends up a cloud on the VPC. Or if it doesn't require that and needs to talk to AWX, we can send up and spin up classic clusters. We've actually made an iteration that we now have these Gen 2 instead of AWX. Now we have a Gen 1, which I'm going to show off as the example here, because it's a little bit more, it's a little bit easier to understand the serverless application. And we run this all in our serverless platform here. So this Kubernetes cluster is just basically an interface. Schematics is there if we need requests for Gen 2, but we actually run everything inside of Code-Engine now. And the beauty of this is that it scales down to 0. So we still have to pay for this, right? Like every company has to pay for the resources they use. And even though we get heavily discounted being IBMers, we still get charged back. And because I'm running all of this inside of Code-Engine and it scales down to 0, this becomes negligible, right? Like negligible cost for me to be able to run this infrastructure compared to what it used to be, which was thousands of dollars a month of just resources of just putting all this all together. Leveraging Code-Engine scales down to 0. And my boss actually asked me at one point, JJ, you're not spending as much money as you used to. Is that a good thing? And I was like, I don't actually know. And when I did the research, it turns out it was Code-Engine saving us a bunch of money because it was just sitting there spinning up this thing every 15 minutes and not finding anything because there's no workshops going on. So nothing gets spun up. And that's pretty damn cool. All right. So as you take a quick moment, and I want to just make a reference to Rube Goldberg here. Yes, it's true. Serverless applications are Rube Goldberg machines. Whoever says they're not, they don't know what a serverless application is, or even if they say they're an expert, they obviously have never run one in production. The challenge of the self-operating napkin exists in the serverless platforms, and you will find yourself doing it. But the beauty of also is as long as you have a standard way of communicating back and forth and have what's the word I'm looking for? Shared contracts between different applications. This doesn't become so crazy, but it's also something worth noting. So let's take a quick little aside, and let me show you some of the actual code, and then we can I know I'm coming up to time here, and I don't want to. Oops, that was not what I was expecting. I did not mean to do that. Let's see here. Where is my? Here we go. So the first thing I want to show right now, I have a couple of these, so bear with me. And of course, I went to the wrong one again. So this right here is an actual one, and I'll throw this in the chat. This is actually out and officially allowed. I don't have the license in here. Don't pay attention to that. There was supposed to be a license file in there. But this is actually the Gen 2 request API, the one that I was talking about sending actual the requests, the actual API that we sent to. We just leverage straight up Flask to do this, which is one of the neat parts of it. Hopefully you can see this. Maybe I should make this a little bit bigger. But as you see, it's just basically creates, it just sits there. It's a Flask API that sits in front of a container that just basically runs a bunch of IBM Cloud commands, right? Like that's all it is. And that's fine, right? we use security via obscurity, and also you would actually have to know exactly the order that our JSON comes into to take advantage of this on our production one. This is just a demo, right? Like obviously this is not what we have on the actual internet, But as you can see, it's just a simple Docker file that literally just sits there and just waits for the requests. And then you give it an API key, you give the request to it. And now instead of me having to parse all that information, it just takes it and runs with it. So if I come back, let's see if I can find my next one here. I'm going to be a little bit dangerous here, and I'm going to show you the actual issue tracker here. So this one right here, this is obviously not out on the real internet. It's on internal, so please don't steal this. But what we have is, I'm not going to show you that. We have a bunch of requests come in, and we have communication where it just basically sends a post request to that exact same API as you see there. This one goes to the classic one, but the beauty of it is back to the request. This is the actual requests that come in. So as you see here, I've had 593 of these since I started that come in, and people put in actual requests in this little format, which is, if you saw earlier, the exact same thing. We have this little issue tracker parse out the information, which I wish I could show you, but I don't want anyone to steal anything from me. And then from there, it kicks off, talks back to it to make sure that it is exactly what it needs to be. I had some bugs, so if you'll see this repeated a few times, and then actually gives us the URL and all that, and then even gives you as a user a link directly to the kubeadmin to make sure that it's up and running how you expect it to, and then gives you a nice little lab and all that. So if I click on this one, for instance, here's that kubeadmin coming up. And the reason why I wanted to show kubeadmin off specifically is something very, very important that I cannot stress enough as an IBM user to this extent is we have this wonderful, wonderful checkbox right here that clicks this delete button. And as you can see here, it immediately kicks over to deleting and is actually deleting that cluster right then and there. The reason why I mention this is I actually checked the amount of clicks inside of IBM Cloud, and to delete one cluster on through the normal interface of IBM Cloud, it was 14 clicks. Yes, that is correct. 14 clicks, and a couple of types of things I had to like copy and paste and make sure, yes, I really wanted to delete it. Now, if on average I have 40 clusters per workshop, there was no way in hell I was ever going to do that, right? Like no way in hell. So now I can click this nice, wonderful big button and hit delete, and it just works. And actually, I'm going to do that right now. Anyway, 1, 2, 3, 4, 5. Yeah. The reason why I can is because I was actually supposed to delete these this morning. So I'm going ahead and do it anyway. But as you see now, imagine that. Like that's it's just beautiful, right? Like it's just great stuff. So yeah. I'm coming up to time, aren't I, Calvin?
No, you've got another 15 minutes.
Oh, perfect. Okay, cool. So let's take a little aside real quick. So let me actually show you some Code-Engine. So if we go into, I did it again. If I grab this one, copy. So let's actually take a quick moment and talk about Code-Engine, where this is the actual interface in all the clusters we have now. So as you take the applications here, as you see, we have multiple different applications running. As you notice that Tech Dojo, if you saw earlier in that link, this is the actual like Grant cluster application that runs our thing. Then I have my Gen 2 requests and my classic requests. Again, what did I just do? I just wrapped this in basically a bunch of Python into a bash script. So if I go look at the Gen 1, that would be too easy. Hang on, classic. So if we take a look at the classic one, because I showed you the Gen 2, but if we take a look at the classic one here, classic one isn't much farther, right? Like, what was I talking about that VLAN earlier? Like, this is literally the bash script here, with just a few different tacks on to make the classic. So what we ended up doing was we created a bunch of serverless functions that sit there and wait for requests. And every time I send another request in, it goes off and runs the exact same thing all over again. And this might seem ludicrous, but the beauty of scaling and leveraging Code-Engine is that when I do now 40 clusters and send 40 requests out to our backend, now it spins up 40 of the different instances of it and does it in parallel from the IBM Cloud. Because I'm running this on IBM Cloud, also hardware, all the API and networking stuff doesn't overrun stuff because it's like, oh, it's all internal. It's all great. So now I've leveraged basically Flask to be a front end to my bash script that I was running on my laptop. So I just came all the way back, just wrapped it in Python. Hopefully that makes sense. And hopefully somebody giggled at that. And as you see, we're smart enough to be able to send it to the different regions too. So now I don't overrun regions. Originally, I had to choose these by hand, which I actually didn't show y'all. Inside of Grant Cluster, there was a way to select the different regions, but I had to figure out, okay, I have N number of clusters in that region, or a number of clusters in the other region. Now, all it spins up and just does the work for me. My friends over in Japan, they leverage this all the time, which is great. To show that they don't have to worry about requesting budget to spin up instances for whatever. They can just literally put their issue in, and 24 hours before their actual workshop, all the clusters are spun up, hence the Tech Dojo. And then 24 hours, or anywhere from the time they asked to stop to the time they, 24 hours afterwards, they it gets deleted. We actually have delete functions too. That come around cleaning everything up also, which just comes off of that, the issue tracker again, because back to the event time, start time, and end time, I have something smart enough to be able to parse 24 hours after the end time and do the request to delete everything for us, which is really, really important because that means I don't have a bunch of clusters just sitting around the place. Obviously, by me coming around and deleting my head time, that's important to recognize. But anyway, I'm babbling again. So as you see, we have multiple different functions here, and that job that I wanted to talk about, which was the cron issue tracker, that is the bread and butter of this thing. It basically sits there and looks for the it looks through each one of the issues constantly, which is really important. It also has a failed workspaces and checks versions. I was trying to create one so it programmatically updates to say, hey, you had 20% of your clusters actually checked out. That was how much money you spent on this workshop or whatever. And that was kind of what this was originally done. It isn't 100% working yet. On another side, which is probably appropriate, actually, I'll just come back to this guy and this one. Come on. I did mention the parsing of the issues, and maybe if you ask really, really nicely, I might be able to have this fall out of a pocket or something, if you get what I'm saying. But this is actually our little parser, and it sits here and it talks to the actual markdown of the issue. As you see here, it gets issue from the body. It talks to the GitHub request repo, walks through each of the ones, parses out the different requests, and creates a nice little blob for us here. And then just does a bunch of checks against it. So for instance, we have make sure that we have an actual email address at the top, right? So like if you don't put your email address in there, it immediately throws an error saying, hey, I can't do it. It makes sure that, the length of the name is less than 15. We have some issues with keys, or not keys, certs. So we have to make sure that the length is shorter than 15 characters. And then if there's some more advanced stuff in here, make sure everything's in the future. Like if it's a workshop or a client, there is that cluster to make sure that it's less than 75, which is pretty neat. And then we make sure that we have enough workers, et cetera, et cetera. And the most important part is where it actually sets these labels. And that is that label check right there is actually what the cron issue tracker looks for. Where is it? And anyway, the point I'm trying to get to is that we leverage the issues here. And as you notice, we have running workshop and scheduled workshop. That serverless function actually flips these tags over as our basically our levers. So if it's set as scheduled workshop, it knows that, hey, this is coming up, and when it's under the 24 hours, it immediately kicks it over to running and then does a bunch of work underneath it, which is really, really important. So that means we don't have a bunch of race conditions. Believe it or not, that was something we ran into a few times that we didn't realize. So we first flip those, but then I can come in and flip them too if I need to, right? And then when we need to close ones, we actually kick it over to be deleted, right? So that one's supposed to, oh, that was a test one. So to be deleted to know that that one has been closed, and then it skips everything. And then the cron issue tracker doesn't even pay attention to it, which is pretty neat. So long story short, right? Like the long story short here is we kind of came together as a way to leverage, we leveraged Python and Bash and serverless functions to take what we were doing on our computer, put a couple APIs in front of it, and then just built up over time, and was able to kind of create the system that was surprisingly robust and surprisingly effective. Let me, are there any other slides? You see some, here we go. Sorry, I have a couple more slides here. It was a really massive, long journey to come to this. And, but now with a /approve, well, we're not quite there yet, but the idea is that we get a /approve, and we use the 4i idea to make sure that everything's okay. And then maybe one day we can just do /approve, and then we don't have to do anything at all. I have a couple hiccups now. I actually ran into a hiccup yesterday, and I'm working around those. But still, the point is it's working quite well. So that's it, really. Thank you so much. Again, awesome at IBM.com. And take a picture of that QR code. That is the actual blog post that I go into more details about this stuff. And if you're curious to the code that I shouldn't, but I did show you, don't hesitate to reach out. I'd love to talk about it more.